Hey YouTube, GeoZane here. I just wanted to talk about 2's complement just to clarify some things for myself and maybe for you. So the cool thing about 2's complement is that there is no negative zero. Zero is always zero. And that's important because it allows us to basically add numbers all the time. So to do subtraction, basically you would do, if you wanted to do a minus b, you would just do a plus a negative b. And so the idea is that we're going to use 2's complement to for negative numbers only. All right. So the rule is basically that if you need to represent a negative number, you're going to do the 2's complement of it, and then if you get an answer that is negative, because it would start with a 1, right? Then you need to convert it back to figure out what number it actually is. So let's go through like a little example of this. This is just in my course notes. So we have 3 and 5 here, represented in binary, 6-bit binary here. And I guess we could think of this as the signed bit. So if we wanted to do a minus b, we're going to take 5 and we're going to convert it to 2's complement, right? So how do we do that? I'm sure there's plenty of videos online, but the way I like to do it is that you keep the least significant 1 and 0, or 0 first and then 1. So in this case, there's no leading 0 here. So I'm just going to keep my 1. That goes there. And then all these bits here are flipped. Whoops. All right. So this is, we get 1, 1, 0, 1, 1. For that is the representation of -5, and then that allows us to add 1 and 1 is 0. Let me just show you what I'm doing. 1 and 1 is 0. Carry the 1. 1 and 1 is, or 1, 1, 1 is 1. Carry the 1. 0, 0, and you get a 1. And then, so you would just do straight addition. Now the thing is that our answer here has a 1 in it, right? So now we know that is a negative number, right? So, but what number is it? If you were asked to say that this is a 2's complement representation, how do we figure out that it is actually -2? Well, we would have to complement it again, do the 2's complement again. So in this case, I'll just write it out over here again. So 1, 1, 1, 1, 1, 0. Okay, so we're going to keep the 0 and the 1. These are the leading bits, and then we're going to flip these. Flip. Keep. And this is just a fast way to do it. Instead of like flipping the bits and then adding 1, forget about it. 0, 1, flip. All right, so we're going to keep 0, 1, and then flip all those. 0, 0, 0, 0. What is this number? This is a 2. But you have to remember, so this is just the magnitude, right? Magnitude. And we have to remember that it's a negative, so this number here is -2, right? So let me show you an example of if we did this. Sometimes you can use a 2's complement to represent the negative number, but your answer is not negative, so you don't have to convert the answer back. And this is the key thing. So instead of doing 3 minus 5, let's do 3. So I'm just going to do this. This would be 3. I'm sorry. We're going to do 5 and a -3, right? So 5 is, let's see, 1 and a 2. Actually, we're going to have to do 1 and a 4. So 0 and a 1. And then all the rest are zeros. Now negative 3, I'm just going to go over here and we're going to do the 2's complement to represent negative 3. So we know that 3 would normally be just 1 and a 2 and all the rest are zeros. But to get the 2's complement, I'm going to keep the 1 and flip the bits. 0, 1, 1, 1, 1. Okay, so now I'm going to put in my negative 3. So that's 1, 1, 1, 1, 0, 1. Okay, and then we know that we can add it. So 1 and 1 is 0. Carry the 1. 1. 1 and 1 is 0, carry the 1, 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 which goes down to here and is a discard. Another cool thing about using 2's complement is that you discard that bit. Okay, so then notice that this is our answer. And notice that we have a 0, so we know that this is positive. And therefore, we do not have to convert it back using 2's complement. We can just read it as straight binary. So I'm going to put here, does not equal a 2's complement. So in this case, it's pretty easy to read that number. That would just be A2 equals 2. And I just want to reiterate that in this case, we used a 2's complement, right, to represent the negative 3, but our answer here was a positive number, and we didn't have to convert it back. Okay, but if we go back to our other example, we had in this case, this was a 3, and this was a negative 5. And then our answer was negative, right? And in order to figure out what the magnitude was, we had to do the 2's complement again. So that's pretty cool. If you just remember that 2's complement is just for negative numbers, right? Whether you get it in an answer or you're using it in your addition, then you're not going to have a problem in terms of representing or figuring out what the number actually is. All right, just remember that signed bit. If it starts with a 1, it's going to be negative. So if it's your answer, you got to convert it back using the 2's complement to figure out what the magnitude is. All right, that was kind of like some confusing things for me, but I hope this video will help anyone else out there. Thanks a lot.